Okay, let's give you guys some more practice. So given these two functions here, f of x is this function here, g of x is this function here, find the domain for this function here. This question is actually very difficult. There are two cunning things that you have to do in order to solve this. Looking at this, remember you've got to put f of x into the g. So you've got to put the whole lot here into the x here, and this here into this x here. And then you would get something really complicated. There are two cunning things that you have to do in order to find a domain for this one here. This question is actually quite difficult. The reason why I'm giving it to you is because I want to give you something difficult so that you know it is possible to solve it. Okay, so well anyway, I wouldn't recommend you try it, but it's up to you. Press pause and have a go. So find the domain for this composite function here. Okay. Okay, so to do this here, hang on. To do this here, looking at this here, you have to put f of x into the g. So when you put this here into this x here, so this is you putting f of x into the x here, and this one here is this one here. Okay, and then you also have to put this whole thing here into here. That's this here. Okay, so you've got something that's really ugly. You've got a function within a you've got a fraction within a fraction. So it looks really complicated at the moment. So you have to really tidy it up. So merge. So you've got three parts here. Merge the three parts together into one fraction, and then do the same down here. So basically, merge these three together, and then merge these three together. So our aim at the moment is just to tidy up this whole thing here. So visualize. Our aim is to merge these three together. So visualize this one here as x over 1, because anything divided by 1 is that same thing. And then leave this one the same. Okay, and turn the 1. Visualize the 1 as 1 divided by 1. Okay, and our aim is to merge these three together as well. So do the same here. Visualize this as x over 1. Leave this one as it is. Visualize the 8 as 8 over 1. Now here in order for you to, so in effect you've got three fractions here. In order to add fractions, all the denominators have to be the same. So here multiply this by top and bottom by x. This one here leave it intact. And this one here times top and bottom here by x. So basically it will become this here. Hang on. So when you times this top and bottom here by x, okay, that will give you x squared over x. Leave this one the same. So that's this here. Times top and bottom here by x. So that will give you this here. And then well, do the same for down here. Okay. And then all the denominators are the same. Look, x. Same denominator, so you can merge all these together. So that becomes this. Okay, hang on. So looking at the top parts here, because all the denominators are the same here, you can merge all these together. So that becomes this. And do the same down here. All the denominators here are the same, so you can merge all these together. So that becomes x squared. So this, merging all these together will give you this. Okay. So now what you've got is this. You've got one if you like one number divided by another number here. That's what you've got at the moment. Whenever you get a fraction within a fraction, try to tidy up. So here visualize this thing as this thing divided by this thing here. It's just like you doing this number divided by this number here. So visualize it as this. You've got this thing divided by this thing. That's what you've got at the moment. Okay, so from here, visualize it as one number divided by another number. So what you've got here is this thing here is this number divided by this number. Now whenever you have a over b divided by c over d, you keep this the same, and then you times the reciprocal of this. So that would be D over C. So you keep this the same, which is A over B. And basically now it's time. So it's top times top, bottom times bottom. So when it comes to this here, you've got a fraction here divided by this fraction here. So in order to do this, keep this the same. So keep this the same. So take this down, and then you times the reciprocal of this. So, well, basically turn it upside down. So so rather than doing this whole thing here, we would times the, well, we would do this whole thing here. Okay, and then so when you turn it upside down, so now it's really a bubble here, timesing this bubble here, top times top. So you can see this bubble multiplying with this bubble. Here it's bottom times bottom. So it's really this thing times this thing here. But the thing is, when you merge them together, yeah, so that there will so this here is now one fraction. So now, well, you can divide top and bottom here by x just to tidy up. So basically, this will kill off. Well, when you are here, you can actually kill these two off. They cancel each other out, leaving you this thing here. Okay, so overall g of x here, when we first met, g f of x, it looks really ugly, but after doing the whole process, it gives us this. The hard part is this bit here. Not so much hard, but the trick here is when you put f of x into here and into here, it becomes really ugly. The trick here is to merge all these together. So turning it into a fraction, and then get all well, the trick here is to merge all these into one fraction, merge all these into one fraction. That's the, well, at the start of the video I said there were two cunning things that you have to do in order to solve this. Well, one is, well, I would class that as a cunning thing here. This is just a trick, a trick that you would use in order to tidy up this ugly thing here. It's just a trick. Okay, so now hang on. So going down here, blah 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 blah. So we are here at the moment. So overall, g f of x is this thing here. Now the thing is, when is it that this function here breaks down? Oh, but by the way, I forgot to tell you. Hang on. When you first meet this question here, you got to ask yourself, when is it? Hang on. When I first gave you this here, you have to ask yourself, when is it that this function breaks down? Well, this function here breaks down when x equals 0. Okay, yeah. So basically, the domain for this function here, is anything. Well, you can write it as x belonging to the real number line, except from the one element 0. If you put 0 into here, this whole thing here breaks down. So just bear in mind that the domain for this function here is, well, it could be anything except from 0. So x cannot be 0. Okay, and then now come to find out the domain for this function here. So we've got to put this into here. So that's us going through all the way, following through all this process here. Sorry, I forgot to sort out the domain for this function. So now back to normal now. So now we are going to put this into here, and then this into here, just so that we can find the domain for this function here. Okay, so that's us putting this into here and following it all the way through. So blah 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 here. Okay, so now g f of x here is given by this. Now you've got to ask yourself, when is it that this function breaks down? When is it that this here breaks down? Well, this breaks down. Well, we don't care what's at the top, because you can have, let's say, 0 divided by 3. That is allowed. But it breaks down when you have, say, 3 divided by 0, or 1 divided by 0, or 0 divided by 0. Anything that divides by 0, it breaks down. So if you see this function here breaks down whenever this thing here is 0. When this whole thing here is 0, it breaks down. So the question is, when is it that this thing here becomes 0? So it's you jumping jumping to the quadratic. It's well, first you got to ask yourself, when is it that this, well, you're trying to solve, you're trying to answer the question, when is it that this whole thing breaks down? Well, this whole thing breaks down here when just this bit equals 0. Okay, so it's you now trying to solve this. When is it that this thing here equals 0? What value of x will, or values of x will make this whole thing here 0? So it really boils down to you solving this. This whole thing here equals 0. This is what it boils down to. Okay, so in order to solve this here, I've done a whole section on solving quadratic equations. So if you don't understand what's about to come, then watch that section. So it's us trying to solve this here. It's us trying to answer the question, when is it that this whole thing here equals 0? You see, now it's trying to solve this. So in order to solve this quadratic equation here, first, in order for us to solve this here, try to visualize the graph y equals x squared plus 1 minus 8x here. So to solve this here, visualize the graph. So quickly sketch your graph. And again, I've done a whole section on this. When x is small, it wants to do this here. So this here is a straight line. So it has an intercept of 1 and a gradient of minus 8. So intercept of 1, a gradient of minus 8. We're going to guess it to be quite steep, a gradient of minus 8. And now when it's big, it wants to do a quadratic. So when it's big, it wants to do something like this, okay, a quadratic. But then you got to compromise. So overall, your graph will look something like this. So when you're trying to solve this, try and visualize the graph inside your mind. And remember, it might cross the x-axis, or again, it might not cross the x-axis. So it could be something like this. Okay, but in order for us to solve this, when it equals 0, let's just assume it, the line does actually cross the x-axis. If we try and find the two roots here, and we can't find those two roots, then we know the graph doesn't cross the x-axis. But let's assume that the graph crosses the x-axis, and then we try and find out these two roots here. Okay, so you see, we are trying to answer the question, when is it that this thing here equals 0? So I'm saying roughly sketch your graph inside your mind. Okay, so this bit here equals, so when this value of x here equals this value of x here, and this value here will make this whole bubble equal 0. Okay, so when is it that what values of x will make it 0? So it's you solving this. So it's you trying to solve a quadratic here. You could use the quadratic formula for it, but I can never remember that formula. So let's just do it like this. Rearrange it. So x squared is like this, followed by the x, followed by the intercept, if you like, and then we want to find out we want to rewrite it in this form here. Okay, so it's us from here we want to rewrite it in this form here. Okay, so again, I've done a whole section on this. So if you don't understand it, watch that section. So we're going to need. We are here at the moment. We want to write it in this form here. Now we're looking at this. We're going to need half of this. So that's this half here. That half of 8 is 4. So it's going to be that, and then well, we remember that if you have x minus 4 and then square it, it's going to give you x squared minus 8x plus 16. You see, these two terms are good. These two terms are good here, but this is rubbish. So we immediately throw away the rubbish, and then well, this one here, you would take it down. So basically, in order to rewrite this in this form here, you would look at these two terms. How would you create these two terms? Well, anyway, you would have to rewrite it as this. Okay, if you don't understand this step, you've got to watch the quadratic section, and then merge these two together. So that will give you minus 15 here, and then blah 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 blah, and try and solve it. So x here equals 4 plus minus 15, root 15. Okay, so look, going back to the original function here, f of x here is this. Remember, the domain for this is it could be anything except from the number 0 itself. So it could be anything on the real number line except 0. Okay. Now looking at this here, remember this function here, this function here breaks down when x is 4 plus root 15 or 4 minus root 15. So what that means is looking at this function here. This function here, sorry, not this function here. Well, the function g f of x. You see, this function here breaks down when this function here breaks down when x is 4 plus root 15. So that means 4 is here, and then root 15 is, well, let's see, 4 times 4 is 16. So I would guess root 15 to be, I don't know, 3 point something, 3.9, 3 point something. So what that means is that the function g f of x here breaks down when hang on, looking at this here, 4 here, so that's 4 here, and then you've got a plus 3.9 ish. So 1, 2, 3 and a bit here. So it breaks down here, this point here, it breaks down, and then 4 minus 3.9 ish. Well, 3 point something. So it's going to be 4 here, and then 1, 2, 3, and then it breaks down somewhere around here. So this is the other point that it breaks down. Okay. So the domain for hang on, the domain for g f of x here is anything on the real number line except from the number 0 because of this function here. Remember, this function here, anything except from 0. So it could be, so the domain for this function here is anything on the real number line except from the number 0, and except from this number here, and except from this number here. So basically the domain here is given by this. Okay?